All right, and we're here with problem number 10 from your Geometry Chapter 8 self-test, where we have a regular hexagon, as I have pictured here, which has a perimeter of 72 millimeters, and we want to find the area of the hexagon. So we know that the perimeter of this hexagon is 72 because we are told it's 72, and we know it's a regular hexagon. So therefore, I know, or we know, that one of the side lengths has to be 12 because all of them are 12. 12 times 6 is 72. So this side length is 12, and therefore all the rest of them are 72 as well. I need the area. If I'm going to find the area of a regular polygon, or in this case a regular hexagon, I need to know the perimeter, which I know, and I also need to know the apothem. And the apothem of a regular polygon is this length right here from the center, and it is straight out to one of the sides, and it is the perpendicular bisector of one of the sides, so I drew it right here. We need to know this length. We don't know that length, and then once we do know that length, we plug it into our area formula for a regular polygon, and then we do our multiplication. We have P, the perimeter, is 72, we know that, so we got to find the apothem. We can do that by drawing a triangle. And we know that in the triangle, this is a 30, 60, 90 triangle because this angle's 30 degrees. This angle's 90 degrees because of the perpendicular bisector of the side. Going back to this 30 degrees, we know this is 30 degrees because I could draw 12 of these triangles around this hexagon. And all of those triangles will be congruent. Therefore, all of these angles right here are congruent, and 360 divided by 12 is 30. That's where this 30 degrees comes from. And if this is 30 degrees, this has to be 60. So it's a 30, 60, 90 triangle we're working with here. And in this triangle, I know that this length right here is going to be 6 because the whole length of this side is 12. And again, the apothem is the perpendicular bisector of that side, so therefore from here to here has to be 6. How does that help me find the apothem? Because again, this is a 30, 60, 90 triangle. This is 6, and in the 30, 60, 90 triangle, the side length that is opposite of the 30 degree angle is x. And the long leg, the side opposite the 60 degree angle, is x times the square root of 3. Therefore, the apothem here is 6 times the square root of 3. And I'm just going to leave it as 6 times the square root of 3 because the square root of 3 is an irrational number. Now I have the apothem, 6 times the square root of 3. Now I can take the apothem and our perimeter, plug it into our area formula, and do the math. 1/2 times the apothem times the perimeter. When I look at this, kind of a mess with that square root of 3, but I see that I can do 1/2 times 72, which is 36. So I have 6 times the square root of 3 times 36. And then I can do 36 times 6, which will be 216. And I'm not going to multiply that by the square root of 3 because it's an irrational number. I'm not going to try to take the square root of that because it's going to be a decimal approximation, and I don't want that. So our exact answer here for the area of this hexagon is 216 times the square root of 3.